last time we went through all the software, and maybe there will be a version 1.1 with some bug fixes. But right now I need to put all this on some kind of board. And I already have a layout for it. So yeah, let's dive in. This is what my layout looks like. And this time I printed it out twice because all the reflections, sorry, uh, because I think a lot of the problems I got last time with exposing the board and etching it were from the parts that shouldn't have been exposed being exposed, and the reason for that being that, yeah, you can see it. What comes out of my printer is not really dark black. So I will try to put two printouts on transparency on top of each other. And I also used this time that rise density of the toner on laser foils, snake oil, yeah, LFA density spray from Huber Chemistry for print. And yeah, last time I used that, I was disappointed, or basically I stated it destroyed the print, and I probably was wrong. The thing is, it makes the printout a wee bit darker, and at least on these transparencies, these are other transparencies, and yeah, I have it, so I used it, and yeah. But now I will cut these out and try to align them on top of each other. I cut out one a little bit bigger and the other a little bit smaller, and now I will try to align. Yep, that's perfectly aligned. I mean, in every corner you can see the tiny little holes, only 0.015 inch. The holes in the pads are just big enough to guide a drill later on when I'm drilling the thing. In my last board I used holes of the actual diameter in the exposure mask, and yeah, that does nothing to guide the drill. So using such small holes in the exposure mask, that leaves just a tiny pit in the copper and helps you to guide the drill. Of course, you cannot put that into a Gerber file and send it out to have your PCB made for you. Then you would have to specify the correct hole diameter. But yeah, for actually etching it yourself, that's perfect. That's perfect. And this time I also added some ground plane. Not that it's really necessary for such a kind of board, but yeah. And two on top of each other is also really, really black. Now all that's left is cut a piece of PCB of that size. This is obviously not to scale. This is just for me keeping track later on where the parts go. Now that I have the board, it's time to put it onto the exposure mask. Come on. And yeah, there are some slight damages at the edges. At least at one edge and at the corner. So I put that edge you see that it's at a spot. It's okay. I put the edge that doesn't look that good to the end of the board where nothing is happening. And now you see why there are these, yeah, small lines. They're just there so I can adjust the position of the board accordingly. So, and if I've done it right, you should be able, yeah, to read the text. For exposing, I will use the half-finished exposure unit, so the controller still on the breadboard, still with the software I reviewed, with a little bug or a few little bugs, but it should be okay. So just put that in here. Close the lid. You see a little problem. I need some cutout here. Okay, nevertheless, switch the thing on. It comes up at 3:15, the time I want to expose. So all I have to do now is press run. Okay, close the lid. I think I can see here when it's finished. And of course, the operate LED will stop. I can actually read the time. And done. That's so nice. So we take that upside down somewhere here on the desk and prepare the chemistry. So nothing new here. We'll start off with 5 grams of caustic soda in 500 milliliters of water, and then within 2 minutes our board should be developed. Yeah, I don't know. It looks good, but there was definitely something eerie going on, like there was a shadow here while exposing. So it took ages for this part to be developed. And yeah, I check if maybe there was some thing on the glass plate. Yeah, you never know. Okay, anyway, etching. So, etching. Nothing new. I will reuse the solution I prepared last time. But now I will heat it up to 40-45 degrees with my laboratory water bath. If you haven't seen it, I cobbled that together. Card link. And of course, now we are working with sodium persulfate. Little bit more aggressive than the caustic soda in really low concentrations. So yeah, I have my nitrile gloves on. And it's already a wee bit blue because there is copper in it from the last time I used it for etching. Normally it's clear, but it's a little blue. We will see if it's still usable or not. But first let us heat up. Oh, did I plug it in? Oh yeah, I plugged it in. Can you see that there in the background? Yeah. Temperature is rising. But yeah, these are from the internal thermocouples, the values. Yeah, have a look at the video. I'm more interested in the actual temperature of the water bath, and therefore I have two thermometers in here, just to be on the safe side. Because you shouldn't heat up that stuff too much. At about, 50 degrees Celsius, a chemical reaction will happen, and yeah, it won't work. If it's too cold, it takes too long. So 40, 45 degrees, and it should take, yeah, 5 to 30 minutes. Depends on the source you're reading. And yeah, my heating element is at 67 degrees C, and that's in the center where really the heater is. And at some corner there's a second thermocouple that reads currently 30 degrees Celsius. And yeah, this will take a while, I guess. Much better than the first attempt. Much better. And etched in about 20 minutes instead of 2 hours. And even my ground plane right here at the edges has survived, but we will see. I put it under the exposure unit for 5 minutes to get the rest of the photo mask off, and yeah, and then we'll see. Yeah, just the second time exposed board back in the developer solution, and yeah, get the rest of the photosensitive stuff off. And I need another solution, not etching or developing solution, another method to grip bigger boards. Much better than my first try. Even these fine details, I mean, this was just me doing lazy layout, survived. That's really interesting. The holes are all there. Okay, yeah, I forgot the holes to put in here. I have to eyeball the 3mm holes there. Yeah, okay, next step, drilling. Not too bad. I really like it this time. Okay, my drilling could be a little bit more on the spot. I have to work on that, but nevertheless, clean it up with some alcohol, some flux spray onto it. Yeah, and then it's solder time. So I have my board, all my parts, most of them are already here on my breadboard. Yeah, additional ceramic headers. Yeah, let's do this. Oh yeah, and I have my silk screen, off screen, and yeah, my circuit diagram with values. The small stuff is all on the board and it looks good, and yeah, here you see one of the drawbacks of using some flux spray on a board. The solder really flows perfectly. I mean, you could tin basically if you wanted to the whole board, but all traces, but there's no need for that. Yeah, now I have to glue in the connectors. I'm using that Loctite stuff long over its well, due date, long after it had all cured out in the dispenser, and I just punched little holes. Yeah, they will seal up by themselves and get some of the stuff out. Yeah, that cured long enough, at least I hope so. And that was soldering the connectors. Ah, I forgot something. The voltage reference slash comparator. No, just put it in the right way. And now for the Arduino. Done and done. Now the only thing left to do is to put it back into the exposure unit and see if it works. Looks much better than that breadboard, but I wonder what happens if I switch on. Hey! Looks perfect. Yeah. And yeah, they come on. So, next step would be to mount that thing somewhere back here. Lots of nice slots for accessing the USB port if I want to update the program and such. No? Till then, bye.